The VSI, vertical speed indicator. This instrument has static only fed to it, except there's a controlled leak from a metering unit. Static pressure goes to the inside of the capsule and static pressure goes to the outside of the capsule, yet inside the casing. There's a balance between the two, which is equal if you're not climbing or descending. If you are climbing or descending, because of the controlled leak, an imbalance in pressures will exist across the capsule, and this will be displayed on the pointer. The VSI is a sensitive differential pressure gauge. It records rate of change of pressure as rates of descent or climb. The pressure change results in a lag between the capsule and outer chamber pressures. This reflects the aircraft rate of climb descent. Compensations for variations in temperature and pressure are achieved by incorporating an orifice, a hole, and a capillary in a metering unit. VSI errors. There's instrument error due to manufacturing inaccuracies. An adjusting screw can be used to zero the needle. Time lag. This is actually quite dramatic. If the aircraft climbs or descends suddenly, there is a delay due to the time required for the pressure difference to develop. Maneuvering errors. Maneuvers or turbulence will cause any pressure instrument to misread. 3 seconds it might take at low altitude or 10 seconds at high altitude. Pitching causes the greatest error. VSI blockages and breakages. If the static line is blocked, the VSI will read 0. Breakage of the static line will cause the static value to change as the break occurs. If the break occurs inside a pressurized hull, the VSI will show a high rate of descent, then stabilize at 0. An IVSI, the instantaneous VSI, is a more sensitive version of the VSI. It's got an accelerometer, dash pots, in the static pressure line going to the capsule. These are basically sort of weights on springs which detect the air pressure rushing in and enable the instrument to indicate the initial rate of change of altitude while we wait for the normal difference in pressure to build up between the normal route in to the outside of the capsule. The accelerometer unit reacts immediately to a climb descent and provides initial differential pressure to the VSI. The output decays after a few seconds, but by then the actual static pressure is effective. The advantages are that time lag and maneuvering error are virtually eliminated. However, turning error is induced as the dashpot accelerometers are not vertically stabilized. At bank angles greater than 40 degrees, the IVSI is unreliable, but arguably we shouldn't be doing that in an airliner. The following images show the VSI firstly in level flight, then in the climb, and then in the descent.